is start solving right triangles. Okay? Within this, most of this chapter is going to be trigonometry. Okay? We're going to start with the Pythagorean theorem, okay? But a lot of this chapter is going to end up being trigonometry. The reason I decided to do this now instead of towards the end of the year is a lot of you are going to be retaking the air test in geometry coming up in December here. Okay? The geometry air test retake is December 4th, and the Algebra 1, if you're doing that one as well, is on December 11th. Okay? So a lot of you in here will be doing that. So we're going to go through the trigonometry right now, which is a big part of the geometry air test, as well as the ACT, if you're going to be taking the ACT sometime this year. Right? So, part of this chapter, there's a lot of vocab in this chapter as well. So, you have the note sheet for today, as well as the vocabulary sheet for this chapter. Okay, so, as we go through this chapter, we're going to fill in parts of this vocabulary sheet. So there's only one thing on the vocab sheet that we're going to go through today, and that is the Pythagorean theorem. Okay, so make sure as you're taking notes today, you fill in the Pythagorean theorem line on your vocab sheet. Okay? So, the Pythagorean theorem is used to find missing sides of a right triangle. And that's important. In order for us to use the Pythagorean theorem, we have to be dealing with a right triangle. And that's a very important idea here. Now, if we look at this model of our right triangle here, we've got our sides labeled as A, B, and C. A and B, the two sides that make up the right angle here, those are called legs. And side C, the side that is opposite the right angle, the one that's not touching the right angle, is exactly the hypotenuse. So, the big idea then, right, for any right triangle, what is the Pythagorean theorem? Do you remember that? What is the Pythagorean theorem? A squared plus B squared equals C squared. Right, so, what this is saying is, if I take the two legs, square each of them individually, and add them together, that will always equal the square of the hypotenuse if we're talking about a right triangle. So we can use that idea to find missing pieces. So let's take a look at number 1 here. Okay, now, before we do anything, we're going to label the sides. Okay, A, B, and C. It does not matter which two sides are A and B. A and B are just the legs. So this could be A and this could be B, or this could be A and this could be B. That does not matter. Okay? But we need to make sure that the side that is opposite the right angle, okay, the one that's not touching the right angle, we always label as C. So, to use the Pythagorean theorem here, A squared plus B squared equals C squared, I'm just going to plug in the values that I know. So A is 8, so we're going to have 8 squared plus B is 13. So 13 squared equals, and then my C is X. That's what I want to find, X squared. So to solve this, we're going to go ahead and square both of these numbers. So we can do that on a calculator. If we don't know these off the top of our head, 8 squared is 64. 13 squared is 169. We still have x squared over there on the right side of the equation. Now I want to go ahead and add these together. Now it's important that we go in this order. Right? we have to square the numbers first and then add them together. Okay, that's kind of a common mistake I see sometimes. So that people want to add these together and then square the numbers. That's mathematically incorrect. Right? We have to use order of operations, and order of operations says we have to use exponents before we add things together. So, what is 64 plus 169?
Is it 233?
233. So we get 233 equals x squared. So I'm done, right? That side is 233? No, why not?
Because you gotta square them. Or, I don't know. I don't. No, it's, you gotta.
We have to get the square away from the x. So how do we do that? How do we undo a square?
I know what it is, but I don't.
Square root, yeah. The thing.
Ain't that what I just said?
You said square.
No, I said square rooted.
Oh, sorry, I didn't hear the root part. I just heard the square part.
Yeah, I said square rooted. So
this then we can put into the calculator. So what is the square root of 233? 14.2? 15.2? I know that the directions say round to the nearest tenth, but let's go to the nearest hundred. I like being a little bit more exact. So 15.26. Ringing some bells? Everybody feel okay with using the Pythagorean theorem here? Alright, then you guys go ahead and try number 2. Set this one up and solve for our missing piece. Remember, make sure you label the sides first, A, B, and C.
How do you find the square root?
So square root semi-convex fractures.
Okay, really?
Shell fiber. Alright, for this one, working my way down, I got the square root of 1213. So what is that? What's the square root of 1213? 34.82.
That's just being
What's
weird.
I rounded my 2 to right. Because the next number next to it was 8, so I rounded to
Oh yeah, we should. It should be 83 then if the next number is 3. All right, you feel okay with these? All right, let's take a look then at the next. Oops, at the next couple examples. All right, so in numbers 3 and 4, we are now missing a leg instead of the hypotenuse. Numbers 1 and 2, we were missing the hypotenuse. Okay, we're going to set this up and solve the same way. We want to label our sides first. So remember, the legs are always A and B, and then the hypotenuse is C. So if I set this up, A squared plus B squared equals C squared. My A is 7. My B this time is my X. And my C is 9. So square both of our numerical values. So 7 squared is 49 plus X squared equals 81. Now, how am I going to get X by itself? This is a tiny bit different than the last problem.
You want to subtract 49 from both sides?
Exactly. We want to subtract the 49 over to the right side. So we'll get X squared equals 32. Take the square root. What is the square root of 32? 5.65. Alright, go ahead and try number 4.
Will you take points off if we don't label?
Look for the A, B, and C.
Yeah. Like, I'm not saying that I'm not going to do it. I'm just saying that sometimes I'll
I mean, the only way I would take points off is if you mess up solving. Like if you somehow said this was A, this was B, and this was C, and then solved it incorrectly.
How do you know?
So A and B are the 2 legs, and by that you mean the 2 sides that take up at the right angle. So those are always A and B, and it doesn't matter between those 2 which one's which. I could have made this one A and this one B. But then the hypotenuse is the one that is opposite the right angle, right? The one that's not touching the right angle. That'll always be C.
Am I wrong?
I don't have to look at it.
He does.
Oh my god. You know that song?
What?
You never heard that? No.
I don't go to church.
It's not even a church song. Okay, well, I had like a really ghetto version of like children's music that my grandma got me from the Pakistan one.
Was it not kids pop? Was it kids too?
I don't know what it was.
Kids too.
But instead of Eliza, it was like Deliza, the children. That kind of, I love that CD. Yeah.
What did your grandmother kind of?
They actually have a PaxSmart. You never been to PaxSmart?
Oh, I
no.
That is not real quick.
You have to No, it's a real thing. It's called PaxSmart. It's a Maslin. For Oh,
I forgot the square root of 19.1.
But I don't think she got it there. I forget where she got it.
Eliza.
Elijah, the children.
What's some other songs on there?
I don't even remember, but that's the one that stood out the most because it went Elijah, the children, the children.
It's early. I got 23.78. Is that what you guys got?
Yeah.
So make sure that you're rounding these correctly. Okay, this one was really 23.7789 or something like that. So since the number in the thousandths place, the number after our hundredths place was 5 or larger, we would round this number up to an 8. Questions so far? Alright, let's take a look at a few shapes that aren't set up just as right triangles as they are, okay? But ones that we could create right triangles in to use the Pythagorean theorem to solve for a missing piece. Okay? So if we look at number 5 here, this is, so if I have two sides of a triangle the same, what type of triangle is that? Remember the isosceles.
Oh,
Equilaterals, all three sides are the same.
oh yeah.
So isosceles is a triangle with two sides the same. Well, our goal is to solve for this height. Does anybody see a way that we can use the Pythagorean theorem to do that?
These are the triangles. I mean, you already have 22. Well, actually, cut the 22 in half.
We're going to just look at half of this isosceles triangle, and that half is a right triangle. And Elijah just told us that that side then would be 11, since we're cutting that side, that base, exactly in half. So I'm looking at this triangle here. Okay, since I know these two sides are the same, this is what I have. I've got a right triangle here with this leg of 11. I want to find the other leg, and my hypotenuse is 24. So go ahead and solve that.
Now restart. We get 21.33. Feeling okay with this? You got me. How about the next one here? My goal is to solve for this side. This is not a right triangle. Right? This is actually a trapezoid. Well, no, we can create a right triangle in this situation.
Does anybody see how we could do that to solve for this length here?
Could you cut it from that one? Going up to, no, not that one. Yeah, no.
Here?
Start at the top, to the left, and then go down. Oh my god. No, like diagonally to the bottom right corner.
Yeah.
Could we do that? Or no?
Well, yeah, I mean, if we're looking at this right triangle, then we would have two unknowns, right? We wouldn't know this side or this side. So we want to try to create a right triangle where we know two of the sides. By the 5? Straight up? Oh. So then this would be the same as this, right? That would be x. So wait, what would this side be then? 13, right? If this is 18 and this is 5, this would be 18 minus 5, 13. So we have now created a right triangle where we know two of the sides. This piece will be the exact same length as this piece, so we can just solve this right triangle for x. So go ahead and do that here.
On the air test, this problem would show up and it would say find the perimeter. It wouldn't say anything about Pythagorean theorem, but you'd have to realize that to find that missing side, you need to use Pythagorean theorem. That's how every question is on the geometry air test. They always combine multiple chapters.
Six tall squares. 6. So, if we look at this number, so if we're wanting right, this is exact. Yep. Did we get 9.33? So, Mrs. Marshall made a good point. Okay? Something like this on the air test. Okay, it could be this exact same diagram. Okay, but it would be like find the perimeter. So we would need to find this missing side, and then add all 4 of our sides together to find the perimeter. Right? So, I mean, it would be, we'd have to go through this process, but then there'd be another step. Right? Most of the questions on the geometry air test are like that. Questions? All right, so let's then, let's take a look at number 9 here, or number 7, I mean. Then we'll jump to the back. So on this one, we have to do a couple of things here to find what we want. Our ultimate goal is to find this entire length here. Well, this triangle does not appear to be a right triangle. Right? We're not told that it's a right triangle, so we can't assume that it is. So, does anybody see a way that maybe in a couple of different pieces I could find this entire length? So our goal is to find this entire length, right? But the big triangle is not a right triangle, right? We're not told that this is a right angle, so we can't use the Pythagorean theorem just with 14 and 29 to find x. So, does anybody see a way that maybe we could find this length in a couple of different steps? Maybe breaking it up. We just want to look at these two right triangles. So we're just going to have to do the Pythagorean theorem twice on this problem. Right? I'm going to find this length, and then I'll find this length. Then to get this entire length of x, I would add those two together. Right? So let's see if we can do that here without my help. Right? So go ahead and give that a try. We're just doing Pythagorean theorem twice here. Right? So we're looking at this right triangle, and then we're looking at this right triangle.
Me too.
When I get there, I'm like, always gotta get stuck behind the school book.
Walk in with like cheese on your face or something.
No, I make sure to brush everything off before I went in. Can't be stupid about stuff like that.
I need me a job.
May have a job out of the law. I go and talk to the lady.
Is it A&A Beauty?
No. Honey beauty is possible.
I just want to see you do. Come on, boy. Sing the bridge. You got like.
No.
I got 26.4 for this first piece, 7.21 for this piece. So when I add those together, this entire length of x, I got 33.61. Is that what you guys all got?
That's awesome.
That's what Bree got, so it must be right. Any questions so far?
No, but I
How about after I talk?
That's like care about a roof.
Alright, so let's jump to the back and take a look at a few of these word problems. Alright, so in all of these word problems, we will be able to model the situation using a right triangle. And then we'll use the Pythagorean theorem to solve for the missing piece. So let's go through number 10 together here. Okay. It says a roofer leaned a 16-foot ladder against a house. The base of the ladder is 5 feet from the house. We want to figure out how high up on the house the ladder reaches. Alright, so model this using a right triangle. We know that the ladder is 16 feet. So where should that 16 go? Is that this leg, the hypotenuse, or the bottom leg? 16 is the hypotenuse, because that's the ladder. And we're saying the ladder leans up against the house. The 5 goes on the bottom. The base of the ladder is 5 feet from the house. So our goal is to figure this height out, how high the ladder reaches up on the house. Now that we have our triangle drawn, this is exactly what we've been doing. And now we're just going to use the Pythagorean theorem. So label A, B, and C. A squared plus B squared equals C squared. So x squared plus 5 squared equals 16 squared. Plus 231. So what do we get here? 15.20. Now, in word problems, we always want to label our answer. There's always some unit we're talking about, right? So this is 15.20 feet. And the ladder reaches 15.2 feet up on the house. Okay. Feel okay with that one? Okay, how about number 11 here? Kurt's building a deck. We're told that it is a rectangular deck. So I know in this problem, I can sketch out a rectangle. Right? And I know in a rectangle we've got all 4 right angles. And it says the dimensions of the deck are 10 feet by 23 feet. Our goal is to figure out the length of a diagonal. What's a diagonal? Slant. So if I were to connect corner to corner here, my goal is to figure out that length. Well, we have just created a right triangle. So go ahead and solve that missing piece there. Find me the length of the diagonal. I got that the diagonal was 25.08 feet. Questions on that? Alright, let's try one more here. See if you guys can do number 12 here on your own. So, since those are on the same side of the equation, the 100 and 529 on the same side, I'm just going to combine like terms. So, I'm just going to add them together and get 60. So, go ahead and try number 12 here. This one looks a little bit different. Okay, we kind of have to think about what east and south means. Yes. Take a look at number 12. Well, it likes you.
You didn't even pick up.
I did.
You don't ever bless you.
That was a call.
No. Take my book.
You're safe.
At Burger King, they're trying to charge people $2.49 for a medium cup of hot chocolate. That's expensive.
That sounds expensive.
Yeah. And I bet you they only use one packet of hot chocolate. Gross. First off. So, made myself a big cup of hot chocolate last night. Walk out.
Hot chocolate.
It is good, yeah. Not that soy and stuff. I hate hot chocolate made with water.
Yeah.
Well,
It's gotta be made with milk.
Sunday evenings, supper a lot of times was just hot chocolate made with milk and cocoa was something less than half of it.
Amish country is really good. Hot chocolate. It's good. Recommend it if you're ever out in Amish country. Ooh, and they sell like the little individual marshmallows that come from like Lucky Charms.
Oh, yeah.
My aunt calls it bibble, but I just think it's the South thing. She's from the South and she's like, "You want a bag of bibbles?" So bibble is this food for marshmallows.
I think they got some of the marshmallows at Green Farms.
Yeah, they do. They sell it there.
All they are is just dehydrated marshmallows.
Alright, for this one, it actually is starting at this point here, and she goes 3.4 miles due east. Well, that would be just drawing a line horizontally to the right from our starting position. Then from there, she goes 5.7 miles due south. So this would be our situation, right? Then we want to figure out from here to here, what's the distance? Well, that would be a Pythagorean theorem situation. I would just take 3.4 and 5.7 as my A and B, solve for C and get 6.64 miles. Alright, no homework.